In this video, we're going to be looking at average rate of change, and average rate of change is just another way of saying slope. There's many different formulas for slope, but we're going to be focusing on this last formula, which may be new to some people. It's the one that's commonly used in higher level maths, specifically thinking about calculus when we're talking about limits. But what's going to be going on is we're going to be finding slope on an interval a to b, which remember the intervals are both x values there in this context. So those will be the values down here. And then we also need the y values, which is what f of a and what f of b stand for, is the y values at those given x values. It's still the same formula as y2 minus y1 over x2 minus x1, or rise over run. It's just in a different format. So it works the same way as slope, just written differently. In this video, we're given the function f of x equals negative absolute value of x minus 1. And then outside the absolute value bars, we have plus 2, which is graphed below. We're asked for the average rate of change on the interval -2 to 2, with both sides being included. So since we're looking for average rate of change or slope, we are going to just write out one of the slope formulas real quick. We're going to be using the function notation one, just as practice for with using that variation of the formula. So f of b minus f of a over b minus a. So replacing the a's and b's, so -2 and 2 are my two x values. So a to b, so just going through and replacing f of 2 minus f of -2 over 2 minus -2. In order to actually find the slope here, I'm going to need to know what the y values are at each of the x values. So, just making a note off to the side. F of 2, if I look at my graph, find the x value 2, which is right there, go to my function. Function is right there. The y value at 2 is 1. And also find f of -2. Finding -2 on the x-axis. Going down to my function, we see that the y value is -1. So we now know our y values, and we can finish going through slope just by replacing them like you normally would in the y2 minus y1 formula. So just continuing, f of 2 is 1 minus f of -2 is -1, as we found, over 2 minus -2. Now I just have to go ahead and simplify this. The double negative there on top makes a positive, so it's 1 plus 1, which is 2. Same thing on the bottom, 2 plus 2, which is 4. And the fraction 2 over 4 can be reduced to 1/2. So the slope, or average rate of change, is 1/2. Again, this is just slope. So just as a reminder, you can, since this is on a graph, we can use one of the other formulas just by counting rise over run, and you can see we rise 2. We go over 1, 2, 3, 4. You end up with the same answer as you would if you used the formula. Okay, in this example, we have a table of values is given for the function f of x. We're supposed to use the table of values to find the average rate of change on the interval -1 to 2. So I'm going to go ahead and jot down average rate of change formula. Again, we're using function notation. So f of b minus f of a over b minus a. So my x values this time are -1 and 2 with a and then b. So f of 2 minus f of -1 over 2 minus -1. So there is the initial setup. And as far as finding the y values like we did for previous examples, we can look at the chart beside us. So for f of 2 is on our chart. F of 2 is 8. And f of -1, found right here, is -1. So we can go ahead and replace the f of 2 with 8 minus f of -1 with -1 over 2 minus -1, and then just simplify the fraction. So double negative makes positive. We have 9. Double negative makes positive. 2 plus 1 is 3. And 9 divided by 3 is 3. So the average rate of change on the interval is 3. Or the slope on the interval is 3. You can also use the formula y2 minus y1 over x2 minus x1. But our goal here is to get accustomed to the function notation and understand how it works in the slope formula. In this video, we're going to be finding the average rate of change of the function g of x equal to the square root of the difference of x and 2 over the interval 3 to 6. So we're going to be using the function notation version for the average rate of change formula, which is f of b minus f of a over b minus a. But one important change with it is since our function is called g of x, we're just going to have g of x's here. Since our function has a different name, we're just going to change the formula to match our function's name. With that, remember that you can always use y2 minus y1 over x2 minus x1. But one of our points here is to be able to use the average rate of change or slope formula with using the function notation. So with that in mind, we're going to continue. So the a's and b's are in the interval. The a is our lower one, b is our upper one. So just filling out the formula to get it set up. G of 6 minus g of 3 over 6 minus 3. In order to actually evaluate this and find the slope or average rate of change, we need to know what the y values are at 6 and 3. So just off to the side, you'll figure out what g of 6 is. In order to find g of 6, remember the difference between g of x and g of 6 is that x becomes 6. Therefore, we will replace on the other side x with 6. So 6 minus 2. 6 minus 2 is 4. And the square root of 4 is 2. So g of 6 is 2. We also need to know what g of 3 is. Doing the same thing, replacing x with 3. So 3 minus 2. 3 minus 2 is 1. So we have the square root of 1, which is 1. So g of 3 is 1. Now that we know the y values with each of our endpoints for our interval, we shall go ahead and plug them in. So g of 6 is 2, minus g of 3 is 1, over 6 minus 3. Now we just have to simplify to finish it off. 2 minus 1 is 1. 6 minus 3 is 3. And therefore we have our average rate of change, or slope, as 1/3.